Hey gang, welcome back. We've been talking about things in space. We're going to come closer to home for these last couple of weeks and look at the forces that shape and changed our planet, and specifically the Keweenaw Peninsula. That's one of the branches of Earth science, the forces that shape and change the planet. Another branch was our place in the universe. Another branch of Earth science is our place in time. We're going to kind of combine our place in time and the forces that shape and change the face of the Keweenaw Peninsula, because this is a story that began a long time ago. Our planet was formed 4.5 billion years ago. Our sun was formed, that cloud of gas and dust called a nebula. All of that. But this rock came to be about 1.1 billion years ago. And this rock, this isn't just part of a pile of rocks here. This is a piece of the Earth's crust. You can't dig down and especially this piece over here. You can't dig underneath it and break it loose. This is attached to the Earth's crust. This is the basement rock. This is a foundation rock of the Earth. And the ones around here are about 1.1 billion years old. You can take a piece of this rock and analyze the inside, and there's certain atoms that decompose over time, and you can look at how much of that atom is decomposed to age a rock. It's called absolute dating, radiometric dating. And igneous rocks, and this is an igneous rock, you can do that with. Because this area has been studied so intensively with Michigan Tech and our mining heritage, we know quite a bit about these rocks. This is a rock, its general type is a basalt. Remember, that's what the ocean floors were made out of, but this was never an ocean floor. This is a flood basalt, it's called. And I know that I know a couple of things about it. I know it was a runny lava spread out in layers. I know that it cooled off rather quickly at the Earth's surface because there's no definite crystal structure. And I know that it flowed out a couple of, about 100 times. There's like 100 different lava flows because we can see layers. If we go down like in a mine shaft, we can see the layers. The top of each lava flow cooled off quicker and formed kind of a skim on the top, and that trapped gas bubbles as they tried to rise out of the molten magma. Those gas bubbles eventually become vesicles, hollow spots in the rock, little tiny hollows, and they're concentrated at the top of each lava flow. Eventually, a secondary mineral will come in and fill up those empty holes. In some places it was calcite, in some places it was copper, in some places it was silver. But it's those vesicles, those gas bubbles that were trapped in each lava flow, that eventually give birth to the copper country. So imagine a billion years ago, North America wasn't the size it was today. In fact, the Rocky Mountains are only a tenth of that age. The Appalachian Mountains are only half that age of this rock. This is an old rock. And the rocks of the Keweenaw in general are pretty old. Rocks around Marquette can be even older. There's some rocks down around Waters Meet that the crystals in them are actually super old, like 3.8 billion years old, 3.5 billion years old. But the rock, it's a metamorphic rock, so that's not quite the age of the rock. But anyway, going back, this is a really old rock. And imagine a billion years ago, 1.1 billion years ago, what will become North America. It's not that big. It's called a craton. The continent is trying to rip itself apart. I mean, we know when continental plates pull apart, we call it a rift valley, kind of like what might happen in Africa right now. But the middle of the United States, and we call it the Mid-America Rift, was trying to rip itself apart 1.1 billion years ago. And when it pulls apart, the crust thins and lava flows out in a long line. And this line stretched all the way down to Missouri and up through under Lake Superior, and then actually curled around and kind of went underneath downstate Michigan, which there's lots of stuff on top of it, so we don't see that at the surface. But lava flowed out over and over and over again in these layers, and the weight of all of those caused it to kind of buckle. And then also about 1 billion years ago, so this has been going on for maybe 100 million years, lava flowing out. And this is before there was life on the land. There was some algae and stuff in the ocean, simple organisms in the ocean. But this isn't like, dinosaurs are a long way in the future still. This is a long time ago. These layers kind of started to buckle, and instead of where the rift was trying to pull apart, about 1 billion years ago, something changed. Maybe the edges of the continents hit other continents, or something changed about the forces inside the Earth, because then instead of trying to pull apart, it started to push together. And it buckled down and pushed up the Keweenaw Peninsula on one side and Isle Royale on the other. So it kind of formed this basin, this trough that Lake Superior is going to fill. Now, we can see that line. It's called the Keweenaw Fault now, that crack where it was pushed up. And we can see the angle of those rocks. And if you drive down Highway 41, you're pretty much driving along the fault. If you go up past Mohawk and you look off to the left along Cliffview, you can see the cliffs that are pushed up. And if you look at the Keweenaw Peninsula, one side is kind of gently sloped and the other side kind of drops right off. And that's because of all of this plate movement. It started with pulling apart, and then it pushed together.